Hello everyone, thanks again for taking a few minutes to watch this video today. In this video we're going to do a very short exploration of solving some equations with roots in them. And we're going to jump right into our first problem here right away. We see two roots on the left side. And how do we undo a root? Well, we want to square both sides. But in order to do this, we probably want to separate those roots from each other. So I'm going to start by subtracting the root x to both sides. Then, how do we undo a root? Like I said, we square both sides. So we're going to square the left, and that square root just goes away. But on the right side, we have this squared. So it's a binomial squared. So 17 times 17. And again, we've talked about this in previous videos. We should all know at least up to root 20 squared in our heads. So 17 times 17 is 289. And then we have negative 17 root x, negative 17 root x, so negative 34 root x. And negative root x times negative root x is plus x. All right, so let's start combining like terms, getting things together. So I'm going to subtract x from both sides. And subtract 289 from both sides as well. And then we're going to divide both sides by negative 34. And finally, if we square both sides again, we get x equals 64. Let's take a look at another one. Root x plus 13 plus root x equals 13. So again, I would say let's bring that root x over here. I'm going to go a little faster with my algebra here now. So square both sides. And finally dividing by negative 26. And squaring both sides. Okay. One more of these, and then we'll take a look at a little investigation here. So subtract the root x to the other side, square both sides, do some subtraction. All right. So now, the big reveal here. An odd number is any number that can be expressed in the form 2n plus 1, when n is some integer, right? So the pattern we've seen here is this, in these first three problems. So let's go back. 17, if we set 17 equal to 2n plus 1, n is 8. And our answer was 8 squared. If we set 13 equal to 2n plus 1, n is 6. And our answer was 6 squared. If we set 9 equal to 2n plus 1, we have 4, and our answer was 4 squared. So what do you think the answer would be to this problem right here? Hopefully you said n squared. Okay? So pause this video here. Just think about what just happened here in these three problems. Think about it algebraically. You can think about it geometrically. Think about it visually. Whatever helps you the most. But get a good example in your head of what's happening in those three problems we did at the beginning. All right, how about this? Now, that was an odd pattern we looked at. Do you think we could figure out this one as well? Let's take a look. So if this pattern holds, our answer should be 3.5 squared, so 7 halves squared, which is 49 over fourths. will the pattern hold for this problem, even though this is now an even number? Let's do the math and find out. So 56 over 16 reduces down to 28 over 8, or 14 over 4, or 7 over 2. If we square both sides, sure enough, it still worked, right? So it's not just an odd number pattern, it's any number pattern. If our problem is going to look like this, root x plus a plus root x equals a, right? We can always do this to find out what our answer would be in the end, okay? What if these are no longer matching, right? Something tells me that this problem is probably not going to hold true to those first four, but let's take a look just in case. All right, so we're here. And we x is 1. So if we set 8 equal to 2n plus 1, like we did in the last one, we get 3.5. And 3.5 squared is not 1. So that pattern is only going to work if these two are matching like we have here. But we still get a nice answer of 1, right? Root 9 plus root 1 equals 4. So 3 plus 1 equals 4 is correct. That's going to work. All right? So that's just a little look, a little deep dive into where we're headed here. We're going to be solving a lot of problems with roots, trying to find some patterns that go along with them. All right? As always, thank you for taking some time to watch this video today, and we hope to see you again soon.